Imagine that you have a boat being pushed across a small body of water with no wind. You know that if you give it a hard push forward, the boat will move forward without moving from side to side because of simple Newtonian motion. However, what if you push this boat forward, and for some seemingly inexplicable reason, it moved sideways without you having to push it in that direction? In the early 1900s, a Polish engineer named Ivan Yarkovsky noted that the heating of rotating celestial bodies could lead to small forces that, over long periods of time, would result in changes in their orbital path. This idea seems complex, but it's very similar to how the boat's path changed. For another example, imagine a road absorbing sunlight during the day and releasing the stored heat at night. As asteroids move through space, they are hit by photons, particles of light that, despite having no mass, still have momentum, and so are able to exert a tiny force on objects, thus the Yarkovsky effect. There are two different parts of the effect that each work to push an asteroid in different ways: the diurnal component and the seasonal component. Because the asteroid is rotating around its axis, the energy that is absorbed is released at an angle from where it was absorbed. Depending on which way the asteroid is rotating on its axis, the stream of photons can either speed up the asteroid, flinging it outwards, or slow it down, bringing it in. This is the diurnal component, the primary effect for objects that are larger than 100 meters in diameter. However, for asteroids smaller than this, the primary component would be the seasonal effect. Typically, these objects rotate much more slowly, so only one part of the surface is left more exposed to the sun for much longer periods of time. Because of this situation, objects dominated by this component spiral inwards to the sun. This inward motion could lead asteroids into the orbital path of Earth, which could cause a cataclysmic event. The Yarkovsky effect is so intriguing that NASA sent a spacecraft, the OSIRIS-REx, to explore a small asteroid known as Bennu and study the texture, morphology, geochemistry, and spectral properties of the surface material, known as regolith, then return a small sample to Earth. When the samples return in 2023, careful examination could reveal the key to changing orbits of asteroids that could impact Earth by taking advantage of the Yarkovsky effect.